All right, so today we are going to pick up where we left off yesterday, which was recognizing properties of quadrilaterals. So yesterday we looked at the square, we looked at a rectangle, we looked at a parallelogram, and we looked at a rhombus. Now, a rhombus, why is that similar to a parallelogram, or why is it similar to a square, or why is it similar to a rectangle? Can somebody tell me?
It has 4 sides.
It has 4 sides. Yes. What else has it got?
Has 4 corners.
4 corners, yes. Has 4 corners. It's like a square that's been squashed, a rhombus, remember? 4 equal sides, 4, so it goes like that. But then the opposite angles are equal. Yeah. Okay, let me get on to sharing my screen then. I've got this, can you see this?
Yeah.
Right, I've got a different whiteboard today so that I've got the dots on it so that I can try and draw them a bit more accurately. So this one we've got here, this is called a kite, okay?
Okay.
There you go. This one's called a kite, all right? Now, a kite is made up of, let me get my lines. Kite is made up of 2 isosceles triangles, bottom to top. Can you see where that red line is?
Yeah.
You see that that's we know what an isosceles triangle is, don't we? What's an isosceles triangle? Aurora.
With a triangle.
Sorry? What's an isosceles triangle?
Isosceles triangle is a triangle that has 2 sides that are equal and then one that isn't.
Perfect. 2 sides that are equal. So we've got a side here that's equal, Aurora, and a side here that's equal. And then down here, we've got a side that's equal and a side that's equal. So it's 2 isosceles triangles put together give us our kite. So they look quite good. They look like a kite. Right, what else does a kite have? It also has these angles here. These opposite angles here are equal. All right. So we've got these opposite angles that are equal. And it has 2 sets of equal length sides. It also has 1 line of symmetry. Okay? Can you draw that in your book for me now?
Yeah.
That's our kite. Remember, 2 isosceles triangles on top. So and as I said yesterday, when you get tested, they may not do a kite like that. They may just try and create it in a different type of way to confuse you, so they might do it at this sort of angle. Like that. So you might see a kite in that shape, turned around a bit. Still a kite. Okay, how are we doing? We've managed to get our kites down.
Yeah, I'm just writing the last bit.
I'm going to share this whiteboard with you
No.
so that you can use it to have a little play around with it. So I'll send it in the chat.
Yep, I'm finished.
Okay, great.
I'm finished.
This is the whiteboard, so you can experiment with making quadrilaterals.
I'm on. I'm finished.
Good stuff.
I'm finished. I finished. Look.
Okay, so I've sent you the link.
My teacher did this.
You got the link, and it says awwapp.com. That's the app. So you can go on it, and it's this whiteboard that I'm using. And because it's got the dots, we can be quite accurate about drawing them. Okay, so we've got this kite. Now I'm just going to move over here a little bit, and I'm going to draw what is called a trapezium. In America, they call them trapezoids. Trapezium. We call it trapezium. Now, trapezium is pretty cool. So it's got one set of parallel lines. So like that. And then the other parallel line, it might not even be the same length. It could just be like this. But it's parallel, okay? Can you see that? Remember, parallel lines, they do not touch. So, and then all we do is we link up the lines. So we just join them up like this. And that will give us our standard trapezium. All right. Now, looking at that trapezium, it's got one set of parallel lines.
There's one in that, I think.
Now, do you think it's got a line of symmetry?
Yes.
Where do you think
that depends? In the middle.
Okay.
In the middle.
You could have a go in the middle, but if I was to do that in the middle like this, you can see it won't fold into itself.
But you can draw it in a different way, so it will.
Oh, here it's not going to. It's not going to fold. If I did it a little bit further up, it's not going to fold.
That would work. That would work.
So this type of trapezium has 0 lines of symmetry. And by all means, give it a go. So it has one pair of parallel sides, and it has 0 lines of symmetry. That's our standard. Yeah, copy that. That's our standard trapezium. However, there is another trapezium, and I'll show you that one in a second when we've got that one down. And that is an isosceles trapezium, or sometimes known as a symmetry trapezium. I'm going to draw you a different trapezium whilst you're copying that one down.
Finished.
So let me just draw one at a different, so it's slightly different. You could get one like this. This is still a trapezium because it's got the parallel sides. Still a trapezium. Let's say, go onto this whiteboard, have some fun, join up those dots. And we've got those two lines, those two parallel lines, and I've just joined up the sides any way I want to. And we can see from that it has 0 lines of symmetry. There's no way that that is going to fold into itself. And that's the standard trapezium, okay? Try and draw a different trapezium if you can, like the one I've done in blue. Give that one a go. How many of you are going to go onto this whiteboard afterwards and have a little play doing the shapes?
Me.
It's quite
Me. It looks really cool.
Yeah, it's a nice one.
I'm just starting to draw the trapezium.
The blue one.
I finished.
Okay.
This is so fun. Do we have to write the thing down?
Yeah, write the properties. 1 pair of parallel sides, 0 lines of symmetry. Yes. Thank you.
No, do we have to write https://awwattp.com/
Yeah, that'll work. But I think if you just put or at, it should work.
But do we have to write it down?
No, because I've sent it to you in the chat, so you should have it.
But do we have to write it down on a piece of paper so we remember that we have it?
Yeah, yeah. If you're not going to remember AWWAPP, AWWAPP. Okay, now I'm going to show you the other trapezium. Okay, so this one is called, it's called a couple of different things. It's known as an isosceles trapezium, or it's known as a symmetrical trapezium. Now, what do you think is going to happen with this trapezium if it's got a name like isosceles in it? What do you think?
I think then that means both of the sides, two sides will be the same. So
Good. Yeah, absolutely. Well done. Yeah. So when we draw this trapezium, we're going to draw our lines. So we're going to draw our tops and our bottoms for our parallel. But the side lengths are equal. So it will look like this. These side lengths will be exactly the same length, like this. So by definition, it is a trapezium because it has the 1 pair of parallel sides, but it's different because we actually have here an equal angle and an equal angle, and we have here an equal length side and an equal length side. The way to look at it is you've created an isosceles triangle and just chopped the top off. Can you see that?
Yeah.
So if I was to create an isosceles triangle like,
Mr. Denton,
yeah.
will the two angles on the top be the same as well?
Yeah. So we've got this one. Let's just count out 1, 2, 3. 5 minutes like that. And then you turn it up. And basically, you just cut it off here and create your isosceles trapezium. So you just chop the top off like a rocket shooting up through the side. So this has a line of symmetry. Where's the line of symmetry? In this isosceles?
Down the center?
In the center. Yeah. So if we were to fold it in the middle, I have to move that over. We were to fold this. The line would be right in the middle there. So let's just draw that line again. In half. Okay, so that's your isosceles or your symmetrical trapezium. So you got that down?
Yeah.
Yeah, everyone's got those down. So you've got kites, trapeziums, and isosceles trapeziums. Yes, we've got that, Lua?
Yeah.
Fantastic. Aurora?
Yeah.
Good. Arthur?
I just don't see any writing with the isosceles trapezium.
Yeah. Have you got the whiteboard up? Yes, you got that? So we've got 1 line of symmetry, 2 equal angles, 2 equal lengths.
Two equal angles. 2 equal. 2 equal what?
Lengths, sides, side lengths. Okay, got that?
Yep.
No.
No? Let's share. Okay.
I'm having a digestive now.
I think that they're going to find a way. Mr. Denton,
Yes?
I finished.
Thank you. Really good. What I'm going to do is on share my homework, I'm going to put up an activity sheet comparing quadrilaterals. And I just want you to write as many of the facts as you can down relating to this shape. Understood? Okay, and then when I see you next week, we're going to be looking at the angles inside of quadrilaterals. So remember what I said yesterday, how much do they add up to? if triangles add up to 180 degrees in sine, what do...
They add up to 360.
Yeah, and the classic example of that is the kite, isn't it? Because it's made up of two isosceles triangles. Put together, 180 add 180 gives me 360. So we can go through our little maths games again, where I give you two angles and you've got to calculate the others. If we've got two equal angles that are missing, or I might give you three angles, you've got to calculate the missing one. So it all adds up to 360 this time for quadrilaterals rather than 180 for isosceles triangles, equilateral triangles, and scaling triangles. Is that understood?
Yeah.
Cool. Okay, right. So you've got everything down that you need. I will send over the worksheet on showing my homework. So your homework is to complete this week. Understood?
Yeah. Yep.
Boom. Have a great weekend, people.
Bye.
You too.
See you on Monday. Bye-bye.
Bye.